Simples, a lot of these ones, we're dealing with sine squared plus cos squared equals 1. So as you have this, we know that this is either in your head or on a piece of paper. And by looking at that, you also know, well, that means you could replace sine squared theta with 1 minus cos squared theta. You could replace cos squared with 1 take sine, and of course, minus sine squared theta would be cos squared take 1. We also have our factorizing skills at our disposal. So if we saw 1 minus cos squared, we could also factorize that as 1 take cos, 1 plus cos, right? We know that we can cancel stuff, and we've got our addition of fractions to go with it as well. We look at this one. I'm feeling green, so we'll go left-hand side, and we expand as per normal. So 1 times 1 gives me 1. 1 times 1 over cos gives me the 1 over cos. Minus cos times 1 is minus cos. And then a negative cos times a positive 1 over cos. So a negative times a positive is a minus. And what's cos theta times 1 on cos? 1. And if you're upset, or you're not upset, but if you're not quite sure, replace it with numbers. So if you had 4 times 1 on 4, you know that straight away is 1. It's some of those techniques. If you're in a test or you're doing homework at home and you can't check, can I do this? Use numbers and see if you can or not. Okay, so that's great. What happens now though? The ones cancel, and we're left with 1 over cos take cos. We're trying to make it look like this. So what is the tactic that we should employ? No. So the first thing I'm looking for is that I've got 2 fractions. I guess I want to try and combine it to 1 term, not 2 different terms. So we're subtracting fractions. We want to get the same denominator. So cos times 1 is cos. We cross multiply, right? So 1 times 1 gives me 1. Cos times cos is minus cos squared theta. And as soon as we see the 1 and the cos squared, we're going, can I replace that with anything? Absolutely. I can replace that with sine squared. And we look at what we're trying to prove. I mean, you don't have to write this step in, but I'm doing it. Sine squared is sine times sine. And we've got that over cosine. And so, of course, that's tan. So that's why, I don't know why I put it there. I did that for the other time as well. That would be over cos. So that's your tan. And then you've got your sine theta, which is your right-hand side. Ha, ha, ha. We've proved it, you suckers. So we just had a question. What's the deal with the A's there? Well, they could use theta, they could use beta, they could use alpha, and they could use a capital A. You'll see that they use a capital B as well. All right, what are we going to do? Oh, yeah, it is the same, isn't it? Oh, how insulting. But if you didn't know that sec is 1 over cos and you just keep staring at it, then it's not so thing. So write it down, 1 over cos minus cos, and that's basically what we just did before. I don't think we're even going to bother finishing that. Agreed? So we did something similar to this last week with the simplifying one, but basically we've got cos theta up the top here divided by 1 take tan. Now I've replaced tan with sine over cosine. And then I'm wanting to now simplify to make one single fraction, which we should be able to do reasonably quickly now because we see this as 1 over 1. So to get it as over 1 denominator, we times the denominators together. 1 times cos gives me cos theta. And then we cross multiply. 1 times cos is cos. 1 times sine, we get the minus sine. We should be able to do that, you know, pretty well by now, and if not, well, you're going to get lots of practice, so we keep on going. And now all that we can do is go, well, I've got this fraction here, replace the divide with the times. I'm a little bit sad to do that because I thought, oh, it would have been nice to just cancel out the causes in a question that we had done similarly before, but unfortunately it's not going to. So now we've got this, and on the other side I've got sine alpha times sine alpha all over sine alpha minus cos alpha, and I'm going, ooh, getting a little bit excited because what's cos times cos? Cos squared. And going, oh yeah, this is cos alpha minus sine alpha. And I tell you, if my denominators, sine times sine is sine squared, if my denominators are the same, I'm very excited because sine squared plus cos squared gives me 1, but my hopes are dashed because the denominator on the left is cos alpha take sine alpha, but the one on the right is sine alpha take cos alpha. They're not the same, but they're pretty close. Would you agree? How were they connected? Yep. Yep. Right, so if I take sine squared alpha all over sine alpha minus cos alpha, and what I'm wanting is I really wanted to add these together, and I can only do that if I have the same denominator, agreed? And you're going, well, they're so close. And so then, would you agree that if I pulled out this minus, I've got cos alpha there, and if it's take sine alpha, isn't that in fact the same? Minus times a minus, minus times a minus gives you the positive. And so that means I can now rewrite this as cos squared alpha all over cos alpha minus sine alpha minus, and you go, oh, well, that's no good either because I really wanted it to be cos squared plus sine squared and cancel out. However, from some of the work that we did previously, I should leave a bit of a gap there because it's getting a little bit crowded. And I can even find it for you to refresh your memory, and that's why we were doing these ones. Look at that. When we had sine squared take cos squared, how could you simplify that? Difference of two squares, absolutely. Whoops. So, yeah, we can do that. So if we can now, would you agree, I can now factorize this with difference of two squares to be, oh, you just missed that. Oh, that can actually be cos alpha minus sine alpha times cos alpha plus sine alpha. A lot of alphas. Cos alpha takes sine alpha. And because there's a times in between there, then I'm allowed to just cancel that out. And so that leaves me with cos alpha, and I'm really hoping that this is my right-hand side. Yay! That's what my right-hand side was. So, look, that is a fairly long-winded one. However, you know, it's just adding fractions, it's multiplying, rewriting stuff. It's a bit like induction, where when you step back and have a look, you go, geez Louise, that looks crazy. But each step at a time, it was just flowing on. It was just rewriting and simplifying. I hope you agree. A couple of hints. Would you believe F looks like the simplest one out there because it's quite small, but I would say that's probably the hardest one. Now the tip is, so write down the tip. The tip is when you're looking at F, there's nothing there that you can replace with, that you can substitute that's going on. So your only options are squaring, or in this case, oh dear, in this case, if you times by the conjugate, right? So, yep, dump it there. So when you times by the conjugate, what is the conjugate, by the way? 1 plus sign. That means downstairs you're going to have 1 minus sine squared. And there's things that you can replace that with. Wait, before you go on your merry way, some of you have gone on and done h, and I think that you came up with a bit of a tip for those playing at home. Moses, what is that tip?
Don't expand.
Don't expand the denominator unless you absolutely have to, okay? So that's your tip. Now, some people expanded and then they had to go back and factorize, so that's okay. But you want to try and not expand unless you absolutely have to. All right, so give you a bit of a moment. Let's see if we can finish the last couple. Can only give you 5 minutes. Thanks, Haydo. So, once you've had a go at those proofs, we are moving on to the double angle formula. Thanks, boys. If you really want to know how the double angle formula came to be, feel free to read, but double angle because you've got the 2 theta in there. This exercise is going to be playing with that a little bit on stuff that we have already done, as you'll see in a moment. When we come to the proofs, we've got 3 options for when we see cos 2 theta, and so a little bit of common sense you will use to decide which one you're going to use. All right, so for 4G, I think we can go, please, question 1. Don't need to do, or if you really want to, you can just whack it in your calculator and be done with it. But all they're asking you to do, does this actually equal? So does sine 2 times 30, so sine 60, will that be the same as 2 times sine 30 times cos 30? It won't be if you, actually it will be if you're in radians as well as, but put it in degrees if you're in, when it says degrees. All right. Number 2, if sine theta equals 4/5 and cos theta equals 3/5, can we find sine 2 theta? Well, yeah, because you can just slap it in here. So 2 times, we're saying sine theta is 4/5, cos theta is 3/5, whack it in and away we go. We happy with that? Same with this, cos 2 theta is cos squared minus sine squared, so you can just square them, pop it in, etc., etc. How are you meant to get tan? What is tan? Sine over cos, so you could just simplify that if you wanted to, so that's going to be 4/3 is tan, whack it in. I wouldn't even bother. When it comes to question 3, same sort of thing, because cos 2 theta is 1 minus, I always forget, is it 1 minus cos squared or cos squared minus 1? 2 cos squared minus 1, so it's this times 2, take 1, it will give you that. Happy? Right. So 1, 2, 3. Skip it if you want. When it comes to the next bit, we've got sine theta, but sine alpha, they don't tell you cos. In order to find sine 2 theta, you actually need the cos alpha, correct? Well, we've done questions like this before, where I know sine alpha, and you had to find cos and tan alpha. This book has gone using cos squared plus sine squared. What do I prefer? No, I prefer the triangle, right? So for this, I would go, it's the triangle. Oh, thanks, Noah. Sorry. No, that's my fault. So what did we have? We had sine theta equals 5/13. Whoever is humming, please don't. So we went 5/13. And so this length here we can find, I stuffed up then, because it's opposite over hypotenuse. So it's 169 minus 25. So what do we get? 144, so that has to be 12. And so now I know what cos is. It's adjacent over hypotenuse being 12/13, and that's what we got here. Why is this negative? Because we're looking at our quadrants. So, we've done that stuff before. You can have a look. You can keep going. Just because the example did it with using sine squares plus cos squared doesn't mean you have to do that. And we eventually roll into the same sort of thing we were doing before, where we were trying to just substitute and replace. So can you please spend half-half. half your time on your investigation, half your time on this, but I would really like to think that if you haven't got up to question 10 on this, you do. Yep. Well, we're skipping 1, 2, 3. Yeah, and you've got Tuesday, Wednesday off. Come on. And let's make it complete 10. Thank you. Goodbye. For you whinging.